हेलो दोस्तों, कैसे हो? मेरे इस YouTube चैनल में आपका स्वागत है।
Right? Design a Cotter joint to withstand a reversible load of 35 kilonewton. The permissible stresses stresses are 80 MPa, 110 MPa, and 70 MPa in tension, crushing, and shear, respectively. So this is the question. Design a Cotter joint to withstand a reversible load. I told you while designing that the load is reversible. So sometimes it's tensile, sometimes it becomes compressive. And the magnitude is 35 kilonewton. The permissible stresses are 80 MPa, 110 MPa, and 70 MPa in tension, shear, and crushing, respectively. Now, as we have seen in the design procedure, whenever we design anything, we first need to know for what load we are going to design. So here we are going to design it for 35 kilonewton, that is given to us. Now, these values of stresses are directly given in this question, but then this is the first question. Just to understand how to solve the numericals, I have taken these values of stresses. Hereafter, these values of stresses will not be taken. We will select the material and then we will find the values of stresses from the design data book. Okay, so here you can see it is directly written permissible stresses. Permissible means allowed. Okay, normal, safe, working, design. Okay, so these stresses we do not have to divide this by factor of safety. You understand this? 80 MPa is permissible. मतलब इतना चल सकता है. Okay, this is not the yield stress. This is not the ultimate tensile stress. This is permissible stress. So you have to keep this in mind that this is permissible stress. So we do not have to divide it by factor of safety. Already the yield stress is divided by a factor of safety, and we got these values. Okay. So you can start like this. Given P equal to 35 kilonewton can be written as 35 into 10 raised to 3 Newton. Then sigma T equal to 80 MPa. So 80 MPa is 80 Newton per millimeter square. 1 MPa is equal to 1 Newton per millimeter square, and sigma C is given as 110 MPa equal to 110 Newton per millimeter square. Now first what will we do? We will design the rod. So you can write like this: design of rods. And what is the notation we have used? D is the rotation for diameter of rod. So you can write like this: considering failure of rod in tension, P equal to pi by 4 d square into sigma t. Also draw the failure sketch here. Whenever you are writing the strength equation, this is called as strength equation. So whenever you are writing strength equation, you should always draw the sketch. Now we know the value of P, 35 into 10 raised to 3 equal to pi by 4 d square into 80. Therefore, d equal to this much mm, 23.6 mm. Now understand here that 23.6 mm is the diameter of the rod. Now you may round it up to 24 mm. That is, we are rounding this 23.6 to 24 mm. Now here when we are increasing, you will always increase the value and not decrease the value, because if you decrease the value, then what will happen? It will fail. Now, when you are increasing the value, what is happening? You are increasing the material. When you are increasing the material, the cost of the product will increase. Cost will increase. Okay. But instead of no this 23.6, maybe it is 23.67 or 23.66, something like this that we have obtained. No, it is to manufacture a product of this dimension and to manufacture a product of this dimension. Okay, here you need some precision. Okay, here it is easy to measure. Okay, so this comes in manufacturing considerations. So when you are increasing the cost of product, at the same time we are reducing the cost of inspection cost of inspection, to some extent. So it is not at all wrong when you are saying that 23.67 is taken as 24 mm, and 24 mm will never fail. If 23.6 mm will not fail, 24 mm will never fail. So you can round it up to some value. No, some students may ask, sir, हम 25 mm ले सकते हैं क्या? Yes, you can take it as 25 mm, but as far as rod is concerned, you can take it to 24 mm also. But if it is a shaft, then we don't get shaft of 24 mm diameter. In that case, we have to round it up to 25 mm only. So that I will explain when I will explain design of shaft. But in this case, you can even keep it to 23.6 or you can round it up to 24. Both are correct. Both the values are correct. And different students may get different answer because some of you may round it up, some of you may not round it up. Okay, so students may get different answers, and these different answers are all different answers are correct if they are within the permissible limit, within the range, particular range. Okay, second is diameter of spigot. It is denoted by D2, and thickness of cotter, that we have taken as T. So how do we solve this? First, we'll draw a failure sketch. So what is the area here? So what I am writing the formula. In the formula, first I have to write area. So what will be the area? Area will be pi by 4 d2 square minus d2 into t, everything into sigma t. If I substitute the value, how I will get it? 35 into 10 raised to 3 equal to that 80 mm will go below this. So it will be divided by 80. Point pi by 4 is 0.785 d2 square minus, I will write here, T is equal to D2 by 4, that is equal to 0.25 D2. So I can write minus 0.25 D2. Now this is the quadratic equation. It can be written as 0.785 D2 square minus 0.25 D2 and minus, how much we get this? 35 divided by 80, 437.5. 437.5 equal to 0. So you can directly find this on calculator. We'll get two values of D2. You will get two values. One is 23.76 and another is minus 23.
Yes, sir.
Okay, so I will round it up to 24 again. So D2 is equal to 24 mm and T is equal to 6 mm. We'll move on to the third step now. Third step is checking the induced crushing stress. Induced crushing stress. So how will we check the induced crushing stress? We'll check the failure of cotter with respect to the spigot. And where does it fails? It fails here in this portion. What is this? This is D2. What is this? This is T. Considering failure of Cotter in crushing with spigot. So what is the formula? P equal to what is the area? D2 into T, and stress is sigma C. So I will write here sigma C induced. So if I put the value of P, that is 35 into 10 raised to 3 equal to D2 is 24, T is 6 mm into sigma C induced. So from this I will get sigma C induced equal to 230, sorry, just to, what is the answer? So we can see now permissible is how much? Permissible is 110, and this is more than permissible. So what will happen here? We can say that therefore design, yes, it is not safe. Design of spigot is not safe, because what will happen? This will fail. Either the cotter will fail or the spigot end will fail in crushing. Here this will get crushed. So what will we do? We will re-evaluate the value of D2 and T. So re-evaluating the value of D2 and T. Now how will we re-evaluate the value? We'll again use the same formula, P equal to D2 into T into sigma C now. Now I'm not writing here sigma C induced. P is what? 35 into 10 raised to 3 equal to D2 as it is sigma C 110. Now T can be written as, again I am writing T is equal to D2 by 4. I am writing the same empirical relation because here I can write D2 by 3 also. Okay. This is correct. This is also correct. But I am keeping the same relation. T is equal to D2 by 4. So it can be written as 0.25 D2. Because we are using now this complete 110 mm. So we'll get the value of D2 as how much? 35.67 is the answer. So I can write it as equal to say 36 mm D2, and T is equal to 9 mm. So now this value of D2 and this value of T will be here used hereafter, and these values, this is discarded. We will not use this value of D2 and T hereafter because this value gives us failure result.
Yes, sir.
Good. Now next what will we find? D1. So diameter of socket. What is it? D1. So what will you write? Considering
Failure of socket in tension.
correct. Failure of socket in tension. Okay, now this is a calculation which will consume half of your time of required for solving the entire sum. This is the cross-sectional area. This one entire is D1 and this is D2 and this is what? T. So we can write here P equal to pi by 4 D1 square minus D2 square minus D1 minus D2 into T, entire thing into sigma T. Substitute the value, it will be 35 into 10 raised to 3 divided by 80 equal to 0.785 D1 square minus 0.785 into D2 is how much? 36 square minus D1 into T. D1 is how much? Unknown. So it will be D1 T. So instead of T we can write 9. So we can write it minus 9T minus minus will become plus. This is 36 into 9. So this can be written as 0.785 D1 square minus Actually, it should be 9 D1 and not 9T. There is a mistake here. Minus 9 D1. So minus 9 D1 and remaining everything will go as a constant. So let us see what is the value of this constant. 1130.86. You can check the calculations and you are getting finally D1 as 44.11 mm. So I will write D1 equal to 45 mm. This is the answer. Okay, now next we'll find D3, diameter of spigot collar. Spigot collar. It is denoted by D3. And how do we find it? We'll find it by considering,
Crushing failure.
yes, crushing failure of what?
Cotter. Spigot cotter.
Yes, correct. Crushing failure of spigot collar.
So definitely you will get that within.
This is what? D3 and this is what? D2. So formula is P equal to pi by 4 outer pi by 4 D4 square D3 square minus D2 square into sigma C. The failure sketch would look something like this.
Hello, sir.
Yes, who is this?
Nachiket.
Nachiket. What
Sir,
happened?
sorry to disturb, but can you go to second step for a second?
Yes, yes.
Diameter of spigot.
Yes, yes. Yeah, here?
No, second step. Diameter of spigot and thickness of quarter.
This one?
Yes, sir. Actually, in this step, I am getting different answers, sir. Because after putting t is equal to d by 4, d by 4, we
It
are
is
getting directly answer of d2 square. So, where is this term of 0.25 d2 came?
See, I will explain this. This is pi by 4 d2 square, that is 0.785 d2 square, correct?
Yes.
Minus d2 into t. T is taken as how much? d2 by 4. d2
Yes,
by 4
sir.
is how much? 0.25.
Yes, sir.
So 0.25 into d2. 0.25 into d2, correct?
But, sir, t is equal to d2 by
D-
4. So 0.25 d2 is value of t. And there is also term of d2. So it becomes d2 into 0.25 d2. So it should be 0.25 d2 square, na?
Yes, correct. This should be d2 square, correct. Okay, this is correct. So how
So
much
now
is
the
it?
value of d2 is coming out to be 28 point something. Just check.
Okay, let me check.
28.58, sir.
Okay, so this is not correct. This should be square and is equal to and next step is 0.535 d2 square is equal to 437.5. Correct.
Yes.
What is the value of d2 that you are getting?
Just a second, sir.
Yes.
So 28 point something 5.
Sir, so 28.58.
28.58. Okay. This is 28.58. So let it be 29 mm. Yes. So this will be how much? Say 29 mm. And T is coming as
8, sir. 7.12.
7 point something.
7.25, sir. So we can consider 7.
7.25. And if you substitute this value here, then how much is the value of sigma C induced? So we'll change this also now. This is 29 into 7.25 into this. So what is the induced value of sigma stress? Sigma C?
166.46.
166.46. Okay. Still it is more than this.
It's greater than permissible.
Okay. So this is correct now. D2 should be 36 mm. Okay. Any other doubt to anyone? Is it clear to all?
Yes, sir.
Okay, that was the mistake. Okay, here this is how much? D3 is how much?
So D3 is 49.26 mm.
So we'll move on to find the value of D4. And this is what? This is T. So what is the what will we write? Considering failure of socket collar in crushing with Cotter. So you can write P equal to what is the area? D4 minus D2 into T is the area into stress is sigma C. Therefore, after substituting all the values, 35 into 10 raised to 3 equal to D4 minus D2 is 36 into T is 9 into sigma C is 110. You will get D4 equal to, what is the answer? So let me write it as 72 mm. Now next, so we have found what? Tensile failures and crushing failures are over now. Now we'll start shear failure. So I'll write, first we'll find A, that is distance from end of slot to end of rod, and we have denoted it by A. And how do we get this? So this is the spigot. This is the slot which elongates here. And this portion comes out like this. So the failure sketch is like this. This thing is D2. This thing is A. And since it is double shear, how will we write? Considering failure of rod end in shear. So you can write P equal to 2 times D2 into A into tau. That is 35 into 10 raised to 3 equal to 2 into, what is D2? D2 is 36, A is unknown, tau is 70. So you'll get the value of A something. So 7 mm. Now 8 is mean width of Cotter. Mean width of Cotter. And it is denoted by P. And how it fails? If this is the Cotter, then it fails from here like this and like this. So we'll get this failure here and this failure here. So if I draw the sketch will be something like this. This particular thing is T and this dimension is B. And this is also double shear. So what will you write? First we'll write considering failure of Cotter in shear. P equal to, what is the area? B into T is the area. Since it is double shear, so it is 2 into tau. So you can write 35 into 10 raised to 3 equal to 2 into B is unknown into T is 9 into tau is 70. After substituting all the values, you will get B equal to, so I will write 28 mm. So A is done, B is done. Now we'll find C. C is what? Thickness of?
The socket collar, thickness of socket collar.
Correct. Thickness of socket collar. That is C. So this socket collar fails in shear, and it fails. This is C. It fails here and here. This is D2. This is D4. Considering failure of socket collar in shear, we will get P equal to D4 minus D2 into C double shear tau. So 35 into 10 raised to 3 equal to 2 times D4. We found out how much? 72. D2 is 36, C is unknown, tau is 70. So after substituting all the values, you will get the value of C as 7 mm. Okay, now the last value, that is thickness of spigot collar. Thickness of spigot collar. And we denoted the thickness of spigot collar by what?
T1.
T1, correct. And how will we get that? And here the failure has occurred. This is D2. This thickness is T. Considering failure of spigot collar in shear. So P is equal to, what is the area? Area is pi D2. Pi D2 is circumference, and into what thickness? T thickness. Now since this is failure in shear on the periphery, so there will not be single or double shear. Okay, the question of single or double shear will not arise because it is periphery, shear on the periphery. So it is pi D2 into T into tau. So we substitute the values.
T1.
Yes.
The T1, na?
Yeah, T1, correct. And lastly, we can write length of Cotter L equal to 4D is equal to, what is the diameter? Shaft diameter, rod diameter.
The 24 mm.
Okay, 24 mm, correct. So this is 4 into 24, that is equal to 96 mm. So this is a complete design 3 for socket and spigot, and factor of safety of 1.5 or 2 for Cotter. Now understand that we are taking factor of safety of 3 for socket and spigot and 1.5 or 2 for Cotter, means we are taking less factor of safety for Cotter. What does this means? If you are taking less factor of safety for Cotter, means what does it means? It means that we are making this as a weak part. We are making or designing the Cotter as a weak part. We are taking less factor of safety. Less factor of safety means the strength of this part will be less, the dimensions will be less, and the strength of the part will be less. Weak part. Which part is weak? Cotter. And what about socket and spigot? See, socket, spigot, socket collar, spigot collar, and rod. All of these are made up of same material. Okay. Cotter is also made up of same material. But what are we doing? We are ensuring that this should not fail. If at all anything fails, then it should be what? It should be Cotter. So we are designing Cotter as a weak part because we want that socket and spigot should not fail. What should fail is only Cotter should fail, because Cotter is a part which can be easily replaced. It can be easily manufactured and it can be easily replaced.